Okay, I'm going to try and make this super quick. We're moving on to, we just learned how a star forms, and we got to the main sequence stage. So just to refresh you, starts as a nebula. The nebula is a cloud of gas and dust. It crunches down, and it warms up to the protostar point where it's like glowing, but it's not fusing yet. And then once gravity puts enough pressure on it, the core will start fusing hydrogen to helium, and that's when the star is born. It's become a real star, and it's in its main sequence stage. So that's where we ended. As long as there's hydrogen in the core, it'll stay in that that main sequence stage where it's in the prime of its life. It's living it. It's awesome. Now, once it starts running out of hydrogen, so as the star begins to run out of hydrogen, fusion slows and gravity pulls the star's core inward. So gravity starts winning, okay? It runs out of hydrogen. It's like, ooh, what do I fuse now? And in that moment of like, what do I fuse now? It pushes, gravity starts to win, okay? Now, here's the thing. So the star begins to run out of hydrogen. That's the big thing. Let's highlight that. And fusion slows and gravity pulls the star's core inward. Okay? So this makes the core's temperature rise to the point where heavier elements can be fused. So this is how we start getting some of our other elements. Once you get past hydrogen, the star starts to die, and we start getting heavier elements, which is freaking awesome. I love it. I love it. All right. The outer part of the star cools and expands to many times its original size. So as gravity is pushing it on the core and you're starting to get other elements, the outside starts to expand, okay, to many times its original size. Imagine our sun as the size of the orbit of Earth. So when our star starts to die and runs out of hydrogen, it's going to expand out and pretty much eat us. We will be inside our sun once it starts to die, okay? So the outer part of the star cools and expands to many times its original size. And that's where you start getting like red supergiant phase, okay? So it's showing you right here, the normal size, the outer part, it's fusing hydrogen. Once it runs out of hydrogen, it shrinks in and starts fusing helium. Shrinks in some more, carbon, neon, oxygen, silicon, until it's iron. And then, like that video you watched before said, it can't fuse anymore, okay? So here we are, stellar nebula. You have the average star. It's going to puff out to the red giant. Massive stars, I think of them as the drama queens of the stars, and they will expand out and be called a red supergiant. So massive stars, they can't just be a regular giant. They have to one up the average star. So they become a red supergiant. They're even bigger. Sorry. All right, so death of a star. What happens to a star once the nuclear fusion process stops and only gravity remains? That depends on the star's size. Okay, so here's this thing that is in your notes that I just went over. The core gets smaller, more elements are created. Okay, so here we go. Death of a star. What happens to a star once the nuclear fusion process stops and only gravity remains? That all depends on the star's size. So for a white dwarf and a planetary nebula, in order to become a white dwarf and a planetary nebula, you usually have a low or medium mass star. So look at this. You have an average star, like our sun. It'll blow up to a red giant star, and then once it can't fuse anymore, it'll kind of puff off its outer layers, and you're left with the hot core of our star, and we call that a white dwarf. Okay? So on these notes, a white dwarf and a nebula and a planetary nebula all come from low to medium mass stars. Let's get to the drama queens. Okay? You can see there's a supernova. It's not just going to puff off its outer layers. It's going to freaking blow them out of here, okay? So in order to get a neutron star, you're going to have a high mass star the core collapses into a ball of neutrons. There's just neutrons hanging out in the middle, okay? But before that, you have to have the supernova. I skipped that, sorry. So you get a red supergiant. It implodes, so gravity wins. It smashes down on itself and then expands out from that implosion. So it collapses on itself with so much force, everything gets shot out. All right. And this, you'll remember from our other video, is how we get all the other elements that we know of. Okay. A pulsar is a neutron star, but it's spinning like crazy. So these are kind of in the same crew. They're made from high mass stars after a supernova happens. Okay. So both of these, so you definitely need to remember it's an implosion. That'll probably be on your test. Okay. And then these two both come from these high mass stars. So these two, I'm going to put them in a different color so you remember these guys are connected. They're both from high mass stars. When you get a very massive star, you're going to get a black hole. Okay. Gravity is strong enough to collapse a star to a point where it is crunched into a single point. Its gravity is so strong that not even light can escape it. Okay, so yeah, it's kind of scary. That's what's at the middle of our Milky Way. So gravity is strong enough to collapse a star to the point where it's crunched into a single point. It's a very, very small, but very, very dense. I would add that. Small, but dense. So dense, it sucks everything in. Okay, those are, so the singularity is somewhere in there. And then this is, I guess, an image of what it would look like. Okay. And that's what you need to know. This image right here, you should be able to label. You will see this on your test. You'll see this on tomorrow's activity. Make sure you can walk me through each step here. Okay. That's it for notes. Have a good one.